From a young age, most of us are taught that there are 360 degrees in a circle. This helps develop other ideas of shape, like the number of degrees contained in a triangle, a square, and other regular shapes. However, when we talk about circular motion and rotational motion, the degree becomes more cumbersome. We need a simple unit to describe the difference in progression of two radii about the centre of a circle. It is at this point that we turn to radians. A radian is derived from a fundamental principle of a circle, its definition by the radius. It has been known for thousands of years that a circle is defined by how far away the perimeter of the circle is from its centre. If you want to make a circle bigger, then you need to increase this distance. This in turn decreases the rate of curvature of the perimeter, as well as increasing the area enclosed within the circle. The distance from the centre of the circle to the perimeter is called the radius, and defines all aspects of the circle. The maximum width of a circle is the diameter. This is simply twice the radius. Any straight line between 2 points within the circle can only ever be smaller than or equal to this diameter. The length of the perimeter of a circle is called its circumference, and is determined by its relationship to the radius. It is at this point that one of the first numbers, not described as a ratio of two other whole numbers, was discovered. It is called pi, and is the ratio of the circumference to twice the radius. The fact that it can not be made as a ratio means it is irrational. Because the circumference is equal to twice pi times the radius, we say that the number of radians within a circle is equal to twice pi. That is to say, we can now describe the full rotation of a radius about the centre of a circle in the form of a clock as twice pi. There are twice pi radians within a circle in the same way there are 360 degrees within a circle. You can see why the radian is a much more natural unit for the angle within a circle. It is derived from the mathematics that describes the properties of a circle. However, it is not rational. We cannot easily imagine what a radian is. Because we cannot easily imagine what pi is. Pi is a number. As far as I keep in my memory, pi has a value in the decimal system of number as 3.14159265135. If you were to express it as a binary number, it would have a different value, as it would in a hexadecimal number system. The point is that pi is irrational. We cannot make it from any two other numbers from our number counting system. The decimal places in pi do not repeat into a pattern that we can change into a more easily tangible number. Pi is different to our everyday life numbers, but is integral to studies of the circle and thus circular motion. You do not need to understand the depths of pi or the radian in order to use it in the same way. You do not need to understand the intricacies of an internal combustion engine in order to drive one. You only need to remember that there are 2 pi's worth of radians within a circle, and how to express angles as radians rather than degrees.